When I'm facing some problem, what I like to do is break it down into smaller parts, so every part is pretty simple to solve. What we did in the explanation video was we go through the array, we swap numbers, we make the array smaller and repeat that. So we have to have some outer cycle that repeats the step that I just named out. And we are repeating them until there is only one number. So for I smaller than input.length minus 1, in each iteration we bubble elements, right? So we go through every number, but we stop when we either reach the end or we reach the number that is in correct place. And since in every iteration biggest number gets to its correct place, and at the beginning there is none, I represents the number of sorted elements. So we loop from 0 to length minus I. But since we are comparing number on index j with number of index j plus 1, we have to stop when j plus 1 is smaller than length minus e, right? Otherwise, we would reach behind the array. And the rest is simple. If the number on index j is bigger than number on index j plus 1, we swap them. And I already explained in selection sort how to do that. So that is all there is to it. Now, as usual, I have a quest for you. When there is no swap in iteration, that means that array is sorted, right? So there is no point to go through the rest. Try to optimize the bubble sort so that the algorithms stop when there was no swap in whole iteration. I suggest you pause the video because in a few seconds I will show you solution. Okay, so we need to have some variable that will tell us at the end of each iteration whether there was swap or not. And since there are only two options, the variable should be of type boolean, right? The variable will contain information about whether the if condition was met at least once, right? So, what if we, before the inner cycle, initialize the variable to false because we did not swap anything? And in the if where the swap is happening, we set this variable to true. That way, if the condition is never met, the variable stays false. And that means there was no swap. And if the condition is met at least once, it will be true. So all we need to do now is to check what value we have at the end. If it is false, we end the algorithm because array is already sorted. And if it is true, we do nothing. Here is the code that does that. So there is the variable swapped, which is initialized to false and is set to true when swap occurred. And in the end of each iteration, we check whether there was swap. And if there was no swap, we return. In other words, we end the algorithm. You may be surprised, but this little change can save us a lot of computation, as you will see in the last video when I test these algorithms. Okay, that's all there is to it. I see you in the next video.